KURINJI Senior Secondary School, CBSE, Namakkal.
Successful result producing school in state every year.
Administered by the Board of Directors with over 35 years of experience in the teaching field.
Special attention on art, craft, music, dance, silambam, yoga, skating and karate.
Focus on Hindi Sabha and Spell Bee Olympiad exams.
Smart class for effective and innovative learning and well-furnished library.
Solitary importance on sports and games in state and national level.
WhatsApp facilities to know activities of students and school inside the campus.
Neet, JEE, IIT coaching experts from Rajasthan and Andhra Pradesh along with our effective teachers.
Admission registration for classes LKG to +2.
KURINJI Educational Institution, Kavetipatti, Namakkal. Admission in progress. CBSE, KG to 12, contact 9025895176. Metric 6 to 12, contact 9344567484. For online admission, log on to www.kurinjischoolnkl.in.
In continuation to the last class, in this class we start with problem number 39 from this chapter, Dual Nature of Light, 14, Neet class. Okay, ma? Right. See here, see this. First, see the 39th question. Photoelectric effect supports quantum nature of light. Right? Photoelectric effect supports quantum nature of light. It's theory, right? This point we got it from theory. Okay. But he is asking the reason, because, right? So he is asking what is the supporting information for this, that is what photoelectric effect supports quantum nature of light. Quantum nature of light. Okay, right. See here. No? There are 4 points. These 4 are not the options. Just there are 4 points. And after that there are options. So like 1, 2, 3 and 1, 3, 4 and 1, 2, 4 and last 2, 3, 4, like that there are different options. 4 options are there, right? So we have to select. For example, these 3 are correct means we have to go for 4th option according to the given options in our material. Okay, right. So what I am saying is here, read every sentence, that is what every statement given here, that is what first one is, there is minimum frequency of light below which no photoelectrons are emitted. This is what we are calling it as, threshold frequency. Threshold frequency, okay, right. So there is a minimum frequency of light below which no photoelectrons are emitted, right? It is the first statement. Second one is, electric charge of photoelectrons is quantized. Electric charge of photoelectrons is quantized. And third point is, maximum kinetic energy of photoelectrons, maximum kinetic energy of photoelectrons depends only on the frequency of light and not on intensity. Maximum kinetic energy of photoelectrons depends only on the frequency of light and not on intensity, right? Fourth point, see here, even when metal surface is faintly illuminated, even when metal surface is faintly illuminated, the photoelectrons leave the surface immediately. Even when metal surface is faintly illuminated, the photoelectrons leave the surface immediately, right? Okay, so they have given 4 statements. Okay, 4 statements are giving information, right? 4 statements are giving information. According to the question, photoelectric effect supports quantum nature of light because, right? So if you observe carefully, out of these 4 points, we can select second, third and fourth, right? So these points are supporting, right? So photoelectric effect supports quantum nature of light means because of these 3 points. This is also the point of photoelectric effect. But these 3 points are supporting to quantum nature of light. Quantum nature of light. Okay. Right. That's why what is the correct option? There are 4 options I told you, no. In which option there is a 2, 3 and 4th, that option is correct. That option is correct. Okay. Right. Next, see the next question. The number of photoelectrons emitted per second from a metallic surface. Okay, right. From a metal surface. The number of photoelectrons emitted per second from a metal surface increases when? The number of photoelectrons emitted per second from a metal surface increase when, right? And this is the statement, you know, that is what when I was discussed the phenomena of photoelectric effect, and when I was discussed the relation, that is what intensity and frequency with respect to photoelectric current, there I told you one important point, right? So important point means it is like an important relation, right? And I told you to remember because it helps a lot. I will repeat once again now. That is what, you know, intensity is directly proportional to number of incident photons. E is directly proportional to the number of emitted photoelectrons per time. E is directly proportional to the photocurrent. E is directly proportional to the 1 by distance square. 1 by distance square. Okay. So based on these 3, okay, right, sorry, based on this relation, you can answer to this question, right? So that's why in our physics, you know, when we are preparing the synopsis, that is what theory, every line is important, right? So based on that relation, just now what I told you, you can answer to this question, right? So you can answer, I need not to say. So what is the answer? The number of photoelectrons emitted per second, the number of photoelectrons emitted per second from a metal surface increase when the intensity of incident light increases. When the intensity of incident light increases. Okay, right. Next question, right? So with this question, that is what with the question number 40, from this chapter dual nature of light, one topic we completed, right? So the topic is photoelectric effect and Einstein's photoelectric equation we completed, right? Now the same chapter, but we are going to discuss the problems based on the next continuation topic, that is what photons and de Broglie wavelength. Photons and de Broglie wavelength. Okay, right. See here. It is what the first question, that is 41, right? See this. The photon of frequency, right? In 41 question, it's very simple. He is asking to write the relation between momentum and frequency and speed of light. I will repeat once again. In 41 question, he is asking to write the relation between momentum and Planck's constant and frequency, that is what photons frequency, right? And speed of light or velocity of light. Okay. So how can we write the relation among all these things? So this is the situation. That is what, you know, E is equal to h nu, we know. That is what E is equal to Pc, we know, right? From these two things, you can write h nu is equal to Pc, no. That is what left hand side is same. Then I can equate right hand side also. That is what h nu is equal to Pc. So that P is equal to h nu by C. P is equal to h nu by C, right? Okay, see here. So in this question, that is what question number 41, he is asking like this. Photon of frequency nu has a momentum associated with it, full stop. If c is the velocity of light, the momentum is, so the momentum is h nu by c. The momentum is h nu by c, right? So like these relations are very important for us to solve the numericals related to physics, okay, and here related to dual nature of light. Next, see here, next question, that is what 42nd question. The idea of quantum nature of light emerged in an attempt to explain. The idea of quantum nature of light emerged in an attempt to explain, that is what black body radiation, right? So in gravitation chapter also we are getting information about black body, but here this is what the idea of quantum nature of light in an attempt to explain, okay. They have given 4 options. One is photoelectric effect, another one is black body radiation, next thermoionic emission, then atomic spectrum, right. So out of 4 options you can select the black body radiation, okay. So the idea of quantum nature of light emerged in an attempt to explain black body radiation, okay, right. Next thing, next question, that is what question number 43. The rest mass of a photon, the rest mass of photon is 0, right, and there are some limitations, that is what limitations means, actually the rest mass of a photon is 0 in free space, right, and there is also relation between the wavelength and this one, that is what rest mass, right. That's why you go through clearly synopsis, then you can decide what is the rest mass in what situation. So here the rest mass of a photon is 0. Next, 44, see here. According to photon theory of light, according to photon theory of light, speed and momentum associated with a photon, speed and momentum associated with a photon doesn't change or do not change or doesn't change as it collides with an electron in vacuum, as it collides with an electron in vacuum, right. So the question is, okay, they will give you 4 options and he will ask that according to photon theory of light, which of the following quantities associated with a photon do or doesn't change as it collides with an electron in vacuum, okay. But here we have to select, right. So they have given like speed and momentum, then speed only, then energy and momentum, then energy only, okay. We can select speed and momentum. Speed and momentum will not change, doesn't change as it collides with an electron in vacuum, okay. Next, see here, question number 45, question number 45, okay, right. See here, small n photons of wavelength lambda, when small n photons of wavelength lambda are observed by a black body of mass small m, are observed by a black body of mass small m, right. Then what is the momentum gained by the body? What is the momentum gained by the body? Right? That is the question. So what is the question, ma? When certain number of photons of wavelength lambda are observed by a black body of mass small m, what is the momentum? So calculate the momentum gained by the body. So we have to calculate the momentum, right? And you know the formula, momentum is equal to E by C. So here also we discussed, that is what E is equal to PC, and here also you can say P is equal to E by C, right? So when momentum is equal to E by C, here you know what is E value? According to the question, it is N into H nu. E is equal to N into H nu. Afterwards, you know, you can write that formula, P is equal to E by C. P is equal to E by C, and you can substitute the value of E, that is NH nu. NH nu. Okay. Thereafter, that is equal to NH nu by C because in denominator c is there, ma. Afterwards, here you know that c is equal to nu lambda formula. C is equal to nu lambda, right? And here if you write nu lambda, nu will get cancelled. The output will be, the output of this that is what momentum will be nh by lambda, right? So that here you can write when n photons of wavelength lambda are observed by a black body of mass small m, the momentum gained by the body, right? The momentum gained by the body is P is equal to nh by lambda, right? So here n is the number of photons, right? Because they have given when n photons of wavelength lambda are observed by a black body of mass small m, right? Then the momentum gained by the body is P is equal to nh by lambda. Okay, right. Next question. That is what 46th question. See here. Photons cannot escape from the surface of A. Right? Is a question. Theoretical question. Simply he is asking. Photons cannot escape from the surface of A. Right? So from where photons cannot escape? Photons cannot escape. Right? Photons cannot escape from the surface of a black hole. Right? Black hole. Right? And photons cannot escape from the surface of a black hole. In the chapter of gravitation, we are getting the information about what is black hole and what happens there itself, right? And how it absorbs the rest of the bodies, right? That and all we will discuss there itself. And now what I am saying is, photons cannot escape from the surface of a black hole. Okay, right. There are different options, like white dwarf, red giant, pulsar, black hole. So out of the 4 options, we have to select black hole. Next question. That is what question number 47. Right. See here, proton and alpha particle have the same de Broglie wavelength. What is the same for both of them? For proton and alpha particle, the question is for proton and alpha particle having same de Broglie wavelengths. Right? The formula for de Broglie wavelength in terms of Planck's constant and momentum. That is what lambda is equal to h by p. H is the Planck's constant, lambda is the de Broglie wavelength, and p is the momentum. Right? You think mathematically, when lambda is same and h is already constant, it will not change. So when these two are same, right? When these two are same, so what about the rest of the factor which is same for both proton and alpha particle? That is what here momentum is same. Momentum is same, right? And think logically and think mathematically. There is one expression which relates lambda, Planck's constant and momentum. That is lambda is equal to h by p. Right? So when h is the constant, that won't change. And according to the question, lambda is also same or constant. Then p value will be same. That is what momentum. You can say that momentum is same for proton and alpha particles because they have the same de Broglie wavelength. They have the same de Broglie wavelength. Okay, right. Next question, question number 48. See here. So from question number 41 to question number 47, these are all theoretical questions and small questions, right? Conceptual questions. That's why I discussed you continuously, right? And I discussed the content directly. Okay, right. And now question number 48, right? See here. Okay, right. The speed of an electron having, right? The speed of an electron having a wavelength of 10 to the power of minus 10 meters is. The speed of an electron having a wavelength of 10 to the power of minus 10 meters is. Okay. So the speed of an electron having a wavelength of 10 to the power of minus 10 meters is, right? It is a problem, a numerical problem. and we have to calculate mathematically, right? Okay, see here, and if you know the relation, it is just a substitution and getting the answer, right? The relation is like this: V is equal to h by m lambda. V is equal to h by m lambda, right? And h value, you know, 6.63 into 10 to the power of minus 34 joule second, and then m value is 9.1 into, that is for electron, 9.1 into 10 to the power of minus 31 kg, and the wavelength value already they have given as 10 to the power of minus 10 meters, 10 to the power of minus 10 meters, right? And you substitute, right? You substitute the values to get the answer, okay? And if you substitute all the things, that is what h value and m value and lambda value, finally we will get it as 7.25 into 10 to the power of 6. 7.25 into 10 to the power of 6 meters per second. Meters per second. Okay, right. And that is what the mathematical process you have to do. And there itself, that is what, just multiplying the denominator things, that is 9.1 into 10 to the power of minus 31 with 10 to the power of minus 10. Then that value will divide this value, that is what, 6.63 into 10 to the power of minus 34. Then finally we will get it as 7.25 into 10 to the power of 6 meters per second, because it is a speed, no, that's why it is meters per second. Okay, right. Next question, see here, that is what, question number 49. Question number 49, see here. What is the de Broglie wavelength associated with an electron accelerated through a potential difference? That is what PD means, potential difference, right? What is the de Broglie wavelength associated with an electron accelerated through a potential difference of 100 volts? Okay, right, see here. And this formula, you know, when we were in a discussion about theory, synopsis, right, there I explained you, right, not only for electron, I explained you for alpha particle, for neutron also, right, and proton also, right. But here, according to the question, we need expression for electron, so that the relation is lambda is equal to 1.227 divided by square root of V, right. V is the accelerating potential, that is 100 volts according to the question, and lambda is the de Broglie wavelength, right. And you substitute the value of V here, because it is available in nanometers, no problem. If options are, options also here given in nanometers, that's why no need to worry about the units. And this is a constant, no, right? So this is the only thing. So anyhow, this expression or formula is available in nanometers, and options also given in nanometers. So nothing to worry about the rest of the part. Okay, see here. It is what, 1.227 divided by square root of 100, right? Square root of 100 means 10, no? Then finally we will get it as 0.1227 and rounding off here. So here if you round off, this 2 will become 3. If you remove this 7, right, this 2 will become 3, and it will be 0.123 nanometers. 0.123 nanometers. Okay, right. Next question, that is question number 50. First I will read the question, then I will go for solution. See here. If a proton and an electron have same de Broglie wavelength, then if a proton and an electron have same de Broglie wavelength, then, okay, right. There are 4 options. So options also for this question, options also I have written on the board. See here. First option, both have same kinetic energies, right. Second option, proton has more kinetic energy than electron. Third option, electron has more kinetic energy than a proton. Electron has more kinetic energy than a proton. And last option is both have same velocity. Both have same velocity, right? So there are 4 options. So question is, if a proton and an electron have same de Broglie wavelength, if a proton and an electron have same de Broglie wavelength, then, so there are 4 options, okay? So out of these 4 options, we have to select any one of the option according to the question. See here, this is like what trial and error method, right? So very careful we have to answer. That's why I have written here a complete answer or solution. And see here. So in the question, from the question itself, we had the information that is what same de Broglie wavelength. And we know the relation for, we know the expression for de Broglie wavelength, that is lambda is equal to h by p, right? So here lambda is the de Broglie wavelength, h is the Planck's constant, the value of Planck's constant is 6.63 to 10 to the power of minus 34 joule second, and this is what momentum, right? Momentum, okay, right. And in the question he told lambda is same, no? Lambda is same, no? Right? Same de Broglie, right? When lambda is same and h is already same, h is a constant, then what about that? Momentum is same, no? Momentum is same, right? We can write. So momentum is mass into velocity, no? So momentum is same means mass into velocity is constant, no? So there are only 2 things. One is electron, another one is proton, right? So see here, mp into vp is equal to me into ve, right? From this we can write like this, no? Vp by ve is equal to me by mp. So it is mathematical, right? Just we are writing Vp by Ve, that is me by mp. Next, see here, Kp by Ke is equal, that is what kinetic energy of proton to the kinetic energy of electron, the ratio of kinetic energy of proton to the kinetic energy of electron. So you may have a doubt why we are moving like this, means based on the options we are moving like this, because we have to judge. We have to judge which of the option is correct, okay, right. And see this, Kp by Ke is equal to 1 by 2 into mp is the same formula, that is of mv square formula, but it is for proton, no? So you have to show of mp into vp square divided by of me into ve square is equal to, this is what mp by me into me by mp. See, vp by ve is equal to me by mp, no? So me by mp whole square. So when it is me by mp whole square, that is equal to, see this, me by mp into, this is what this is square is there, no ma? Me square by mp square, here it is mp by me, no? So one will get cancelled because we are having opposite terms here. So the resultant of this equation, this expression or this term will be like this, me by mp, right? So Kp by Ke is equal to me by mp, and the mass of the electron and the mass of the proton are constant values, that's we know. So based on those values, we can say that me by mp is greater than 1. Me by mp is greater than 1. So when me by mp is greater than 1, we can say that kinetic energy of proton is less than the kinetic energy of electron. Otherwise, you can also say that kinetic energy of electron is greater than the kinetic energy of proton, okay, right. So whatever it may be, based on this we have to select third option, that is what electron has more kinetic energy than proton. When third is correct, automatically second is wrong, no, right? And this also we cannot say, that is what both have same velocity also we cannot say. But finally we can say that kinetic energy, right? Kinetic energy for electron. So electron has more kinetic energy. Electron has more kinetic energy than a proton. Okay, right. That's what we can say, and we can conclude here, right? In this class we discussed more problems, because some problems are conceptual and small. Okay, see here. So from 39 and 40, from the last topic of the same chapter we discussed, and then we came here to the next topic of the same chapter, photons and de Broglie wavelength. There we discussed important conceptual questions, right, from 41 to 47. Afterwards we started numericals. So there 48th question. So we calculated the speed of electron, so which we got 7.25 into 10 to the power of 6 meter per second based on the given information. And then we discussed the 49th problem. There we calculated de Broglie wavelength of electron based on the given potential difference. Afterwards we discussed the 50th question. Based on the given information, we found and we determined kinetic energy of electron is more, right? Electron has more kinetic energy than a proton. Okay, right. So in our next class we will start with 51 problem. Thank you.